Okay, students, now we are going to talk about the weak bases. Weak bases are very similar to the weak acids. They also ionize very little in the water. And the concentration of hydroxide concentration from the weak base is very less. So if you assume it's not going to be equal as like strong bases where the concentration of a base is equal to the concentration of hydroxide generated from the bases. Now here is an example that ammonia react with water and form ammonium plus ion and OH minus ion. So in this case, the ammonia generates OH minus, and this you can see an arrow where you can see both ways. It shows it's a weak base. If it's a strong base, you only will see a one side arrow. Finding the pH of the weak base solution is similar to the finding the pH of a weak acid. Now we'll see some examples of weak bases. Now here you can see carbonates will react with water and form bicarbonate and OH minus. So you can see that OH minus is generated. And here you have see a methylamine where it generated the OH minus, and again ethylamine, ammonia and pyridine and a bicarbonate aniline. So you can see all these things are containing a negative ion or lone pair electrons. So this will cause an H plus to absorb. As a result, an OH minus is generated from water. So this is the basic concept of weak bases. Now these are the structures of amine where they all act as a weak base. So if you see an amine, most probably it can act as a weak base which can grab a H plus from water and generate an OH minus. Now we'll see how to find the pH of a weak base. Now we have taken 0.1 in ammonia solution. Then we will write the draw the ICE table. The ammonia is in the reactant side and ammonium and OH minus in the product side. So we don't include the water as it's a liquid. So initial concentration is going to be 0.1, and we assume. Okay. Now first, for initial concentration of ammonia, it is going to be 0.1, but ammonium and OH minus is 0. And now we'll see a change as minus X from the reactant. It's going to be minus X, and in the product side is going to be plus X, which is formed. And the equilibrium is going to be, for initial concentration of ammonia, is going to be 0.1 minus X. Yay. Now we'll use the, what we are looking is, we are going to write the equilibrium constant. So here the product side should be ammonium plus, and the OH minus are the product on the top. The bottom is going to be ammonia. So here we are generating an OH minus, so we call that Kb, which is the equilibrium constant for bases. Now we'll see, now once you plug all those values, you get this equation, and then we simplify this equation as you assume that minus X is very small, and we assume it's the initial concentration will be the equilibrium concentration, and we are going to solve for X. So once you solve for X, you will get 1.33 10 to the power minus 3. So this is very similar to what we learned for weak acids, but we are generating the OH minus. So if you know the previous work well, this will be very easy for you. So once you know the X, here is you're going to substitute. First of all, now we did an assumption, so we are going to see whether this assumption is valid. So we use the X divided by the initial concentration, which is 0.1, and multiply by 100, which is 1.33, and that is less than 5%, so our assumption is valid. Now we are going to substitute these X values to the concentration value, and then that means the ammonia concentration and the ammonium and OH minus concentration. So once we know this, now we know the OH minus concentration. So if now the question they are asking is the pH, that means we should know the H plus concentration. So we already learned that H plus and OH minus, the relationship between that. So we can use this equation, that is Kw equals H plus and OH minus. So we can solve for H plus, which will give you 7.52 10 to the power minus 12. Now we know H plus concentration, and we use this equation, the pH equals minus log H plus concentration will give you 11.124. So this is very similar to what we learned. Only thing is here in this equation the OH minus is generated, so we are going to write for Kb. So we can check our problem whether we answered correctly by putting all this equilibrium constant, and then we can find the Kb. So we can see here the Kb is 1.8 10 to the power minus 5, which is close to the 1.765 10 to the power minus 5 given in the question. Okay, now we are going to talk about the acid-base properties of salt. So this what we are going to learn here will help you to put your input for the lab we did it on Wednesday. So we know by looking at an acid or base, we know it's acid or base by looking at H plus or H minus, or whether electron hydrogen acceptor or hydrogen donor. But now here we are going to look at is the salts. So we know when you mix H plus and OH minus, you are going to form salt. So salts are like soluble ionic compounds which does not accept or grab protons or donor. I mean they don't accept or donor protons. Now for example, now here is sodium bicarbonate. So you can see sodium carbonate is formed from sodium plus and bicarbonate. So sodium, how is sodium formed? Sodium formed from it's a salt. It's generated from acid-base reaction, is formed from sodium hydroxide. So that means sodium hydroxide formed from strong base. It is formed from strong base. So we know if it's come from sodium hydroxide, it is only a forward reaction. So the sodium is not going backward reaction to form the sodium hydroxide. So sodium stays as it stands. It is not going to grab or lose any H plus. So that means the sodium is act as a neutral, right? Okay. Now you can say the bicarbonate. So bicarbonate, how does the bicarbonate comes? So the bicarbonate comes from the bicarbonic acid H2CO3 and release H plus and HCO. So that means bicarbonate is a conjugate base of a weak acid, right? So it's a base. That means it can grab an H plus. So it can grab an H plus. So that means it can act as a base. As a result, what you can say is when the salt get together, sodium is neutral and the bicarbonate act as a weak base. So altogether this salt is going to be a weak base. I mean it's very basic. It's a basic slab. So like that we are going to conclude how the acid-base properties of salt. Now we'll take another example, that is ammonium chloride. Ammonium chloride, you can see it's formed from ammonium and chloride. So ammonia, how this ammonium is formed in water? From ammonia plus water. That means ammonia is a base. What is ammonium is? It's a conjugate acid of the weak ammonia, right? It's a conjugate acid. So the ammonium is an acid. It's a weak acid. Then chloride, how does the chloride comes? It's from HCl. So we know hydrogen chloride strongly dissociated to hydrogen and chloride. So once its chloride forms in the water, it's not going back. So it is neutral. So when chloride and ammonia form the salt, that salt will be acidic. So that's how we are going to decide whether a salt is acid or base, by looking at the salt. Whether the salt is from a strong acid or base, it's going to be neutral. But if it's coming from a weak acid or base, it's going to be acid or weak base. Okay. Okay, now we'll see the same argument we are going to talk about here. Now, the stronger the acid is, the weaker the conjugate base is. Now, for example, the same thing what I explained, we are going to explain a little bit more here. Here, chloride will act with water and form, the chloride is formed from hydrochlorine. How it is formed? Hydrochlorine will act with water, hydroxide, and form water and chloride. So here you can see when the hydrochloride form chloride after reacting with the base, this chloride is not going backwards because it's the arrow is backward and there is no arrow for both sides. So the chloride is neutral. Okay, so the stronger the acid, what happened? The conjugate, the base is going to be weak, or it's going to be neutral. Okay. Now here, now example, an anion that is conjugate base of a weak acid is basic. Now for example, now HF, it's a weak acid. It's not strong like HCl. So this can go forward and backward. So once it's formed the fluoride, the fluoride can grab H plus and go backward. So it forms a base there. So if the anion of the conjugate base, okay, of a weak acid is going to be basic. Okay, so the stronger the acid, whatever the conjugate base is going to be a neutral, but if the weak acid, it's going to be basic.